All right. Okay. Salmanani, Limela. How are you? Salam alaikum. I hope you all good, right? Here's our question. Here's our question, right? So we only gonna be doing number B. Mashallah, right? Okay. I'm gonna try and draw everything and then write what we're given, and then we'll take it from there, right? Okay. We're given a question, let's say problem 3. I'm gonna rush things a little bit, right? Because the video is gonna be very long, so that's why I'm gonna try to rush things. All right, cough is coughing. Okay, we're given a shaft, right? Yes, here's our shaft. Shaft. Okay, this is our shaft, right? In our shaft we have a bearing here. This is our bearing, right? And then we also have a bearing here. This is our bearing, right? Okay, and then we have a pulley here. Pulley. The nigga that has 2 tensions, right? Okay, and then we have a gear set here. We have a gear set here, right? Have a gear and then a pinion. So look at this. Here the pinion and the gear, they are mounted on the same shaft, right? So they're gonna have the same power. Okay, this bar, right? Okay, this one also I can do bar. Yes, it doesn't matter. So let's write the distances, right? This is A, B, right? C and D. The distances is I love things in meters. 0.3, 0.3 and 0.16. These are our distances. The distances between the bearings and the pulley and the gears. Okay, right? And then what else do we have? Okay, our gear is not acting in one direction. It's not acting only in the Z direction or in the Y direction. Okay, let me write my directions here. This is gonna be bar, our Y, bar, our X, bar, our Z, X, Y. Okay. Mashallah, it's a little bit cold. That's why I'm kind of shivering. But then, okay, let's write what we are given. Firstly, let's start up here. We're given the diameter of the pulley, right? Diameter of the pulley is 300 millimeter, which is 0.3 meter, right? 2, we're given the pressure angle. Pressure angle is equals to 20 degrees, right? Okay, let's read the statement. The driving shaft carries a pinion Q. This is the nigga Q, right? A pinion Q having 36 teeth rotating at 1,240 RPM with the module of The teeth are of The pinion with a face width, most of the things given here, right? Okay, the pinion with a face width of 42 millimeter delivers power to a gear to the rider's shoe, right? Okay, like most of the things that are given here are to design the gear, right? But here we're designing a shaft, so we only want to pick up the thing that we're gonna name, right? We think we're gonna name. So we are given a power. So in this time is the power is of everything. So power is 15 kilowatt, and then we're given the speed, N is equals to 1240 RPM, right? And what else? Okay, we're given the coefficient of friction here. Coefficient of friction between the belt and pulley is 0.32, right? And then we're also given a groove angle, right? 2 beta is equals to 32 degrees. Let's mark down. All right, we're given the groove angle is 32 degrees. We already know the formula that we're going to use. If we're given something like this, we already know that 2.3 log, right, T1 over T2 is equals to coefficient of friction multiplied by the angle of contact, and then cosec beta. This is not the whole groove angle, it's half of the groove angle, right? Because the groove angle is 2 beta. And we also know that cosec is equals to, let me say cosec theta, right, is equals to 1 over sine theta. Okay, 2 things that you're supposed to check. And then what else do we have to check? Diameter opinion given, gonna use it to find the torque, and then what? I'm taking things from there. Okay, sure. I think we wrote everything that we're probably gonna need. Oh yeah, this also, okay, we'll just get there. We get there eventually, right? Whoever came up with the word eventually came up with a good word. Like, if you work hard on something brick by brick, eventually, like little by bit, eventually you'll get there, right? So the person who came up with the word eventually, shout out to the nigga. Okay, let's solve this. Firstly, let's concentrate on the gears, right? On the gear set, right? Yeah, gear set, right? Like I said, both the pinion and the shaft, they are mounted on the, the pinion and the gear, they are mounted on the same shaft, so they want to have the same power, so everything's just going to be the same, right? Let's find the torque. Torque is equals to 60p divided by 2 pi n, right? Good. So it's gonna be 60 multiplied by the power, which is 15 times 10 divided by 2 pi n. Our speed is 1240, and then our torque is equals to 6. Don't dash, bro. 60 15 times 10 divided by 2 pi n. Okay, so our torque is 115.51 Newton meter, right? Okay, after finding our torque, let's find our tangential force on the gear. Our tangential force, F2, is equals to that torque that you found, the very torque that you find, divide by R, right? And here we're gonna say F2, yeah, F2 is equals to torque, which is, wait, am I doing right? Force is equals to torque over R, so torque is equals to force multiplied. Yes, okay, yeah, I'm doing all right. Okay, torque, which is 115.51 over R. R is of the drive, all right, of the pinion. So we wanna say the radius of the pinion. We're given the diameter, that means our radius is gonna be 0.15. F3 is equals to, let me say 0.3 divided by 2 is 0.15. So it's gonna be 115.51 0.15 115.1 115.51 divided by 0.15 is equals to 770.067 Newton, right? And then the radial FR is equals to FT ton pressure angle 770.067 ton 20. Bear with me if I'm rushing. I just because I know this video is going to be long. 0.067 ton 20 770.067 ton 20. Okay, that is our radial. It's gonna be 280.281 Newton. That is our radial force on the gear set, right? So we found the torque, we found the tangential force, and we found the radial force, right? The force is gonna be acting downwards, like on the y-axis, right? Okay. And then what else? Not bad. Where do I get this? What else? Oh, what else? I break different. What else? My wife Beyonce. What else? What else? What else? Okay. And the gear, I think we're not given the mass. That means we don't consider the weight of the gear, right? Okay. Now let's check the pulley number 2. Pulley. Okay. On the pulley, we have tension 1 and tension 2, right? Which is tightest slack. Mashallah. Slack is CKS. Yeah, slackest. Yeah, I hope. Yeah, but then I think I'm right. Okay, like I said, there's 2 formulas that we're going to use here, right? The torque is equals to T1 minus T2 and then multiplied by the radius of the pulley, which is the torque we found it. Hey? We found the nigga 115.51 is equals to T1 minus T2 multiplied by the radius of the wait. Something I remembered. This is the radius of the pulley, and I used it to calculate the gear. Is of the pulley. This one, okay. Let me finish this first. The radius of the pulley, that means is 0.15, right? That means T1 minus T2, right, is equals to 115.51 over 0.15. So T1 minus T2 is equals to 115.51 over 0.15. 770.06. Good, very good. That means T1 minus T2. This is question 1. Yeah. And then the mistake here that I wanted to talk about, I used the radius of the pulley, whereas I'm supposed to use the radius of the pinion. And then looking at this here, we are not given the radius of the pinion. We have to find it first. You gotta find me, nigga. You have to find it first. So that means all this is wrong. Okay, from here, going, right? Let me just circle it so that it doesn't confuse you guys. But then I'm a man too, right? I make mistakes. I'm a man, right? A man has to make mistakes and learn from them, right? Yes. So bear with me. Okay, this should be the radius of the pinion, right? But then we don't have the radius of the pinion, so let's calculate the diameter of the pinion first. The diameter of the pinion is equals to its number of teeth and the number of teeth of the pinion we're given. That means it's 36 multiplied by the module. The module we're given is 3. So it's gonna be 36 multiplied by 3, which is 108 millimeters. This is the diameter of the pinion, right? Diameter of the pinion is equal to 0.108 meter. Okay, now that means its radius is 0.108 divided by 2. Its radius is 0.054 where meter. Okay, good. That means here the FT, right, the FT, this one, where we made a mistake by dividing with the radius of the pulley, whereas we're supposed to divide with the radius of the pinion. It's gonna be 115.51 over 0.054. That means FT is equals to 115.51 over 0.054. Mashallah, 115.51 over 0.054, right? So it's 2139.07 Newton. That is our tangential force, right? And then our radial is gonna be FR is equals to 2139.07 ton pressure angle, which is 20, I think. 20, yes. So that means our radial force is going to be 219.07 ton 778.55. You see, this was going to cost us 280, 770, whereas the real answer is 2139 and 778. Good. Thank God that I saw that mistake. Thank God. Thank God. Okay, back on the pulley. Like I said, if we're given the groove angle, then we already know which formula we're going to use, right? We're going to use this one and just substitute everything, right? And here I said a cosec is 1 over sine, right? And then we're given a groove angle. That means 2b is equals to 32, but we want b. We want billion. We don't want 2 billion. We want billion. So it's gonna be 36 divided by 2, which is 16. Okay. 18. Fuck. Yeah, ne? It's 18. Decrease. Yeah. Okay. Now let's plug everything in this formula and then solve for the tensions. Yeah, it's 2.3 log T1 over T2 is equals to coefficient of friction we given is 0.32 multiplied by the angle of contact we are not given, we give it pi, so it's gonna be 1 over sine 80, right? All right. Okay, so here it's gonna be, I'm just gonna put everything here on the calculator and divide by 2.3. So here it's gonna be log T1 over T2 is equals to 0.32 pi 1 over sine 80 3.25. Okay, 3.25 divide by 2.3. Next page, nigga. All right, we're getting there break by break, like I said, eventually. Okay, That means our T1 over T2 is equals to inverse of log, and then I don't know if 3.253 over 2.3. So that means our T1 is equals to, let me punch everything in a calculator. Punch as in fruit punch. 3.253 over 2.3. 3.253 over 2.3. okay, it's gonna be 4.1138 T2. Okay, wait, let me just check if I did everything. 3.253 over 2.3. Alright, and then you say the inverse. Mashallah, we have another equation number 2. Let's go. So we have 2 equations, this one and this one. Let's just substitute everything back and find this tiring tensions, right? So T1 is equal to 4.1138 T2. We substitute it here. 4.1138 T2 minus 1, right, is equals to 770.06, right? That means 3.1138 T2 is equals to 770.06, and then divide. Even your little brother and your little sister can divide. 3.1138. 3.1138 T2 is equals to 770.06.3.1138. So divide the 247.306 Newton. So divide. All right, that means our T1 is equals to 4.1138 multiplied by T2, right? It's this one. T1 is equals to 4.1138 multiplied by 247.306, right? T1 is equals to multiplied by 4.1138, 1017.36 Newton, right? We found both our tensions. We did what? We found both our tensions, nigga. Yeah, we found both our tensions. We found this one and this one. Yeah, I thought they had us the first half, right? But then we bounced back. Okay, now here's the confusing part. I don't even know. Okay, well, number 1, number 2, number 3, number 4. Yeah, number 4, right? Number 1, number 2, number 3, number 4. Okay. Now, okay, let me cut it here. Okay, in the next video, what are we going to do? We're going to find the components of the tensions. Why? Because the tensions are not acting in one direction. Right? We want to find the components and then draw the shear stress diagram, find the bending moments, and plug into the formula, right? But then, yes, mashallah, curves out.